Hello, my name is Nathaniel Jose, and today I will be discussing my Physics 2212 Lab 1 charge tape. So, to introduce this lab, the purpose of it was to observe the interactions between charge tape and other objects, in order to estimate the charge it accumulated, as well as the number of electrons that were transferred during the charging process. The key ideas that we're going to be discussing in this lab are electric fields, vectors, Coulomb's law, and gravity. Some necessary formula that you need to know before completing this experiment are the electric field formula, Coulomb's law, and the basic force of gravity formula. So, to overview this lab, how will the charge tape interact with other objects? And what can we learn from the interactions between this charge tape and objects with known charges? As well as can we use this information to estimate the charge of the tape? So for this experiment setup, we have a separation distance between tape A and the fixed tape B at a distance of 2.2 centimeters or 0.022 meters. The mass of the upper tape, tape B here in red, is 2 times 10 to the negative 4 kilograms. The length of the upper tape is 8 inches or 0.2 meters. And lastly, the width of the upper tape here is 0.5 inches or 0.0127 meters. The system for this experiment is going to be tape B, and the surroundings are going to be tape A, the supporting books, and gravity. So there are 4 key assumptions that we are making in this experiment, and those are that air resistance is negligible, the charges of the tapes can be interpreted as a point charge at the center of each tape. The tapes were handled properly throughout the experiment, and that both tapes are the same mass and have the same charge. And this charge is distributed evenly across the tapes. Some preliminary math that we did before are doing the glow script calculations is that F gravity, force of gravity, is equal to the force of the electric field, or mass times gravity is equal to your K constant times your charged particles squared over the distance squared. And after finishing the calculations, we end up with 1.027 times 10 to the negative 8. So here's a look at the model and the code to go along with it. As you can see here, we're using the same equations, force of gravity and force of electric, to calculate our final number, which happens to be the same as we calculated earlier on paper, where the blue dot is tape B and the red dot is tape A, and the two force lines are equal in length. So, what if the signs of the electrons and the protons were flipped? Our observations would not change, besides losing protons rather than electrons. The same result will occur, that the tapes would repel each other. All other findings would remain the same: forces on the tapes and their interactions between the tapes. So, why is it important to handle the charged tapes as little as possible? When the tapes come into contact with your hands or other neutral objects, the tape may also begin to neutralize itself by gaining back some of its electrons, and this would have skewed the experimental results. Thank you for your time.